So this is Integrated 1, Semester 2, Final Review. This is classwork number 5 on Unit 9, Inequalities. So the one thing to remember is when we are solving inequalities, you can solve them like an equation with the exception of one situation. When you are multiplying or dividing by a negative, you're going to switch the direction of your inequality. Otherwise, your inequality is going to remain the same throughout your problem. So on this first one here, I am going to add 5 to both sides. I am going to end up with 2x still greater than 18. I'm going to divide by 2. And since I'm dividing by a positive 2, my inequality is going to remain the same direction. And my answer is going to be x is greater than 9. Okay. So let me write that down here. X is greater than 9. Then on my number line, I'm going to put a 9. I'm going to have an open circle. And since it's greater than, I am going to be shading to the right. And that is my graph. On number 2, for this one, I personally would multiply both sides by 4. So I'm going to be having 4 times the quantity x minus 2 over 4 greater than 4 times the 5. So I'm multiplying both sides by 4. I'm doing this to fraction bust. So this 4 and this 4 are going to cancel out. And I'm allowed to multiply or divide by a positive. My inequality does not change. So this is going to be x minus 2 is greater than 20. I'm going to add 2 to both sides. And adding 2 does not change the direction of my inequality. So I'm going to get x is greater than 20. So x is greater than 20. So I'm going to put 20 here. This is going to be an open circle. And I am going to be shading to the right. On C, in this situation, I can either distribute my -5, or I actually could divide this side by -5 and this side by -5. Now, when I divide by a negative, well, first off, when I divide by a -5 on both sides here, this time I'm going to get x minus 1. Because I'm dividing by a negative, I am going to change the direction of my inequality. It was less than or equal to. Now it's going to be greater than or equal to -2. Okay, and again, I did that because I divided by a negative. I'm going to switch the direction of my inequalities. Let me just write that in red over it so it's a little brighter. Okay, so I am going to add 1 to both sides. And I'm going to have x is greater than or equal to -1. So that is going to be my answer. Put a -1 here. This is going to be a closed dot. And again, I'm going to shade to the right. Now, in this next section, these are absolute value equations. So when I have absolute value equations, my first step is to get my absolute value isolated, okay, all by itself, and that is, so when it is by itself, the next thing I'm going to do is I'm going to look to the other side of the equal, and I want to see what sign this is. This is a positive 19, so I'm going to write my 2 equations. If it was a negative, my answer would be no solution. So this is going to be 2x minus 5 is equal to 19. Because the absolute value of 19 is 19. Or it could be 2x minus 5 equals a negative 19, because the absolute value of negative 19 is also 19. I'm going to solve both of these. So I'm going to add 5 to both sides. I get 2x is equal to 24. I divide by 2, and I get one answer as x is equal to 12. Over here, I'm also going to add 5 to both sides. I get 2x is equal to a negative 14. I divide by 2, and I get x is equal to negative 7. So those are going to be my two solutions. Now, when I'm looking at letter B, again, I want to make sure my absolute value is isolated. It is. Then I look to the other side and see what sign it is. If it is negative, okay, then it's going to be no solution. So since negative, no solution, because there's nothing I can take the absolute value of and get a negative back. So my answer here, no solution. Now on letter C, my absolute value is not isolated, so I want to get it by itself first. So I am going to add 2, and I am going to have the absolute value of x plus 4 is equal to 9. Now my absolute value is isolated, and when I look to the other side, I have a positive 9. So I can write my two equations. So one equation is going to be x plus 4 is equal to 9. The other one's going to be x plus 4 is equal to a negative 9. I'm going to minus 4 from both sides. And I get x is equal to 5 is one solution. I'm going to minus 4 over here. And I get x is equal to negative 13 is a second solution. On letter D, this is an absolute value inequality. Okay, so for an absolute value inequality, first thing you want to do is get your absolute value by itself, just like we did in the other problems, and it is. So now I am going to actually think of this as an equal. I'm going to think about really solving absolute value of 2x plus 4 is equal to 16. Okay, so I'm going to write my two equations. So I'm going to have 2x plus 4 is equal to 16, and 2x plus 4 is equal to a negative 16. I am going to minus 4 from both sides. I get 2x is equal to 12. I divide by 2, and I get, as one of my boundary points, x is equal to 6. Okay, I'm going to subtract 4 from both sides. I get 2x is equal to a negative 20. I divide both sides by 2, and I get x is equal to negative 10. So both of those are boundary points. So I'm going to have a negative 10 and a 6 here. Now, these are both going to be open circles, and either I'm going to shade in between or I'm going to shade out. Now, one way to think about that is because this is less than 16, I want things that are less than that distance, not greater than that distance. And that would actually mean that I'm shading in between instead of out. Okay, but another way to do it is to actually test it. So a good number to test is, I like to test a number inside in between these two numbers. So let's say 0, for example, is in between those. So if I put 0 into my original inequality here, okay. So I'm going to go absolute value of 2 times 0 plus 4 is less than 16. So 2 times 0 is 0 plus 4 is less than 16. So absolute value of 4 is less than 16. And the absolute value of 4 is 4. So is 4 less than 16? That is true. So I'm going to shade where the 0 is, which means I'm going to shade in between. The way I'm going to write my answer, start with your smaller one, -10, less than x, also less than, they just have to go the same direction, 6. So it's everything in between -10 and 6, but not including -10 and not including 6. Okay, so these ones are ones where we're going to graph. Now, when we do this, if our line, okay, y is greater or y is greater than or equal to mx plus b, where our y is by itself on one side, everything else is on the other side, then both of these situations we're going to shade above. If our y is less than mx plus b, or less than or equal to mx plus b, we're going to shade below. And we have to pay attention to whether it's greater than or less than, which would be dashed, greater than or equal to, less than or equal to, which would be solid. Okay, so on this first one, my y-intercept is going to be 4. So I'm going to start up at 4. My slope is 1. So I'm going to go up 1, right 1, up 1, right 1. Let me just get my graph. In this situation, this is going to be a dashed line. So let me just get my line tool. Okay, so I'm going to have my line, and let me just kind of move that. It is going to be dashed. So I'm going to make it dashed. I don't know why it's not letting me do that with that. I'll do it with this. Okay. So it is going to be dashed. And since this is greater than, I'm going to shade above. So when I'm shading above, I am going to come here, and this is going to be above, this is going to be below. So I'm going to be shading everything above that line. So anything in this shaded region is a solution. Anything on the line is not, because it's dashed. On B, my y-intercept is going to be a -3. So I'm going to start at -3. My slope is a -3 force, which means my negative I like to do with the top. So this is going to be down 3. And so you do your top as up if it's positive, down if it's negative, and then always have your bottom just go to the right, unless you're running out of graph space. So I'm going to start here at -3. I'm going to go down 3, 1, 2, 3, and right 4, 1, 2, 3, 4. So when I say, or if you're running out of space, so instead of going down and right, I can go backwards, which is up and left, up and left. Okay. Now this one's going to be a solid line. So let me draw my line here. And so let me get my arrows. Okay, and then this one is y is greater than or equal to. This one over here was greater than. Both of these were shading above. So this one I'm going to shade above. So I'm going to shade everything above this line. So everything in this shaded region plus the actual line is a solution because it's a solid line. Now on C, this one's not in Y form, so let's get it in Y form first. So basically, I'm going to add 2x to both sides. So I'm going to get 2x minus 3. And now I'm going to be shading above because this is greater than or equal to. Make sure you get it in y form before you decide. So for this one, my y-intercept is going to be -3. My slope is a 2/1, which means up 2, right 1. So up 2, right 1. This is going to be a solid line. And then this one I am also going to be shading above. It says greater, so I am going to shade above. So I'm going to be shading everything above this line. So everything above plus the line is going to be a solution. On D, it's not quite in Y form, almost. So I am going to divide by 2, divide by 2, divide by 2, each separately so I can see my slope. Now this x/2 really is a 1/2 x. 8/2 is a 4. So my y-intercept is going to be 4. My slope is a 1/2, which means I'm going to go up 1, right 2. So up 1, right 2. Down 1, left 2. And this is going to be a solid line. And for this one, it's less than or equal to, so I am going to shade below. So I'm going to shade everything below this line. Oops. So everything below plus the line is going to be a solution. Now on the next one, it says solve the following systems of inequalities. Be sure to show your solution. Let's see. These seem like they ended up not being here. So let me just pause for a second. So I'm going to blank this out on mine and it won't be on yours. This is actually on the homework. So these problems here that they want us to do are on the homework for tonight. So don't worry about that. The last problem is these inequalities here. And that's the end of this video.